Honors Algebra 2, Chapter 8, Section 6, the last section of the chapter. Our goal is to be able to solve our rational equations. So we've discussed rational expressions before. Rational expressions are going to be fractions, and these are fractions where if you divide them, you get a decimal that will either repeat or terminate, just means stop. And we've dealt with rational functions here, and so we're going to be solving these. So rational equation, an equation that contains rational expressions. So you have the fraction, numerator, denominator, or they could be polynomials in the numerator and denominator. To solve these, the methods we'll be using today is to cross multiply, if possible, so you have to know when you're allowed to cross multiply, or to multiply by the LCD, the least common denominator, to both sides. So those are techniques we're going to use to actually solve these equations. So the first method for solving is solving using cross multiplying. You're only allowed to use cross multiplying technique, or the means extreme property is sometimes called, is when you have two fractions equal to each other. It's got to be a single fraction. Numerator denominator equals a single fraction. It's the only time you're allowed to cross multiply. And when you cross multiply, get in the habit of writing the cross product, which means you actually write down the diagonal multiplied together. So if you actually multiply that out, you get x squared minus 4x equals the other diagonal. And get in the habit of writing that down. Write down the cross product. This is the evidence or work I'd want to see. And so we have to solve this. So I would want to put it in standard form. So subtract 12 to both sides. And then solve this quadratic by factoring. And it would be x minus 6 and x plus 2. So then we get 6 and negative 2. For this one here, same thing, write the cross product. And if you want to do some factoring, we can do that as well to help us out. But I would first just multiply through here. So 2 times the y squared minus 9, writing the cross product, equals y plus 3 times y minus 3. And so if we multiply, it's 2y squared minus 18 equals, if I FOIL here, we get y squared minus 9. So I'm going to put it in standard form, move everything to one side. So I'm going to subtract y squared, so I get y squared here. And then I'm actually going to add 18 to both sides, so I get 9. And I can square root, so y is positive and negative 3. So means extreme, or the cross product, is the first method. If we have a problem like this where you have a fraction plus another fraction, now we can no longer use cross multiplying to solve this. So now we're adding these fractions or multiplying by common denominator. So using your skills from the previous sections here, I look at the denominator of x, 3, and x. If I multiply both sides by 3 times x and distribute that, is actually going to get rid of all my denominators. So I'm going to multiply each of these terms by that. So if I write that out, it's 3x times 2 over x plus 3x times 1 over 3 equals 4 over x times 3x. So I can reduce. This x reduces with the x. 3 times 2 is 6. Plus this 3 reduces with the 3. X times 1, which is x. This x reduces with the x, so I get 12. So subtract 6, x is 6. So this is a nice technique. It actually eliminates the fractions. So you just have a simple equation or that you can solve using your previous knowledge. So the last few problems here are just similarly going through how you can multiply by the common denominator. So I multiply this one by 15x and 15x. If I do that, 5x goes into 15x 3 times. 3 times 2 is 6. I have to distribute the 15x to both of these fractions. So I multiply the first fraction, the 15 reduced with the 15. I still have the x times the negative 3. And then for the second fraction, the x is reduced by 15 times 1. So I'm going to subtract 15 to both sides. So I get negative 9 equals negative 3x. Divide by negative 3, so x is 3. For this one, I can use the common denominator, multiply it both sides, but I notice how there's a fraction equals a fraction. So I would go to cross multiplying. X squared equals 1 times that denominator is just x plus 6. Put it in standard form. Then see if you can factor. It'll be x minus 3 and x plus 2. So then we get 3 and negative 2 as my solutions. Okay, more complicated. last two problems. We have the two fractions here, so I cannot use cross multiplying. I could add these fractions, so I can use cross multiply, but I'm not going to. I'm going to multiply the common denominator. Now, to find a common denominator, I'm going to first factor this denominator. It factors to x minus 7 and x minus 2. So the other fractions over here has x minus 7 does not have the x minus 2. This 1 over 1 doesn't have either one. So I need to multiply both sides by that denominator. And so we could write this out. I'm actually just going to multiply both sides by x minus 7 times x minus 2. And multiply this side by the same thing, x minus 7 and x minus 2. So it's going to be multiplied to both of these fractions. The first fraction, the x minus 7 is reduced, and I have x minus 2 times 3. If I distribute that, it's 3x minus 6. Those two binomials times the 1 is going to be those two binomials, x minus 7 times x minus 2 equals, and this entire denominator reduces with that common denominator multiplying by, and I get 8. So I can combine the terms here, but first to multiply. So I get x squared minus 9x plus 14. Put it in standard form, so that's x squared, 3x, negative 9x, that's negative 6x. Then I have a negative 6 and positive 14, but I'm going to subtract this 8 as well. So I'm going to end up getting 0, and so that equals 0. So I can just factor out x minus 6 equals 0, so I find x is 0 and 6. You could back substitute to see if that is actually a solution. Let's test it. So for this one, I have x minus 1 as a denominator. I have x plus 5. If I factor this one, this is x minus 1 times x plus 5. So it has that same two denominators. So I multiply both sides by this trinomial, or those binomials, x minus 1 and x. So this reduces with the entire common denominator. So I get negative 24 on the right. On the left, I'm going to distribute to the first fraction. The x minus 1's reduce. And I have x times x plus 5, which is x squared plus 5x. And then if I distribute to the second fraction here, be careful, we have a minus. So minus parenthesis, the x plus 5 is reduced. So I have x minus 1 times 3x. But be careful of that minus sign, because that minus sign is going to distribute to the entire quantity. Let's first distribute the 3x. So we have 3x squared minus 3x. So then I can distribute the negative. Then I can put it into standard form. So I have a negative 2x squared plus 8x. And then add 24 to both sides. So I can factor out a negative 2. And I'll do with x squared minus 4x minus 12, which will help me factor that. So x, we get minus 6 plus 2. So we find solutions of 6 and negative 2. So be very organized in your work, show what you're doing to both sides. Call that good for the night, and we'll see you tomorrow.